All right. Good morning, ladies. Happy Friday. All right, we made it through another week here. That means we have what, 9 days left until winter break. All right, and this week we had our common assessments. Um, I'm very impressed with the grades that I received from this class. Shout out to Miss Nivea with the highest grade in this class with a 90. Was it a 90? Was it? It was a 90. Great job. All right. So today we are going to go over a few questions that was on the common assessments to review. And then afterwards, I'm going to release you guys to finish the rest of the questions on your common assessment breakdown on your own. So I just put a link in the chat for you to go to whiteboards. So go ahead and take this moment and log in. And let me share my screen. All right. You okay over there? All right. You may need your periodic table, so go ahead and pull that out. How can I save this with the background? All right, I just pushed our very first question. So what I want you to do is take about a minute and 30 seconds and annotate the question and solve. So I'm going to put my timer on for a minute and 30. Oh, it's still taking a minute to come up? Let's see. Okay. All right, we got about 10 seconds left. Come on, Caitlin. All right, let's see. Who's gonna explain first for us? All right, Juliana, volunteered instead of being voluntold. All right, so I am going to click on your screen. And can you walk us through what you did? I'm going to mute myself so everybody can hear you.
Okay, so the first thing I did was was count how many electrons are surrounding the nucleus. So I got 5 electrons, and then out of the outermost shell, I saw they had 3 valence electrons. And so I went to my periodic table, and the only one I saw with 3 valence electrons and 5 electrons was a boron.
All right, good job, Juliana. All right. All right, so make sure you are using your periodic table. Your periodic table is your best friend. We will be using that for ACPs, STAR, Common Assessment, and weekly tests. All right, let's go. Let me find another one for you guys. Let me delete this one. And let me give y'all some a little bit more challenging. Let's see. Make it a little bit smaller so you can see everything. All right, here is another question from our common assessment. It says a teacher asked a student to write a chemical equation for photosynthesis. The student's response is shown below. The equation is not balanced currently. Which one of these balanced equations, which one of these is a balanced equation for photosynthesis? All right, so I'm going to give you, let's say, 2 minutes on this one to annotate and answer. All right, we have 45 seconds left. All right. I see that a few of y'all are still working, so I'm going to give you an additional minute. All right, we got about 30 seconds. Let's go ahead and start wrapping up. All right, I am going to pick on Miss Jennifer's. All right, so Jennifer, can you walk us through what you did to come up with D as your answer?
So I did a RAP chart and I did the reactant and the product. Is that what it's called?
What was that?
Is it called the reactant and product cipher? Yes. Okay, that. And I did them for each answer choice. And just like in A, it says the. It's, I don't know how to explain it, miss.
It's okay, keep trying.
Okay. So I just kind of counted them, I guess you can say. Yeah, that. Sorry. And then the only one that was balanced was D.
All right.
How to explain it?
All right, so Jennifer made an REP chart for each one of her answer choices. And as she completed her REP chart and she recognized that they are not balanced on each side, she eliminated them until she came up with the one that was balanced, which was D, where excuse me, where there was 6 carbons on both sides, there was 12 oxygens on both sides, and there were 12 hydrogens on both sides. All right, remember, in order for our equations to be balanced, you must have the same number of atoms on your reactant side and your product side. All right, good deal. Let's see. We want to pick one more for us to do before I release you to finish the rest on your own. All right, I just pushed another question to you. It says 4 students race toy cars on a track. The mass and the acceleration for each car is recorded in the table below. Which toy car had the greatest applied force? I'm going to give you 2 minutes to calculate. All right, we got about 30 more seconds, but I see that y'all are still working, so I'm going to give an additional minute. All right, let's see. Miss Nivea, can you explain to us what you did to get your answer? I'm gonna mute myself.
Okay, so I used my formula F equals m times a, which is mass and acceleration, and I multiplied all the masses and acceleration together, and the greatest one was the toy car number 4, which was 0.525, and so I picked J.
Oh, great job. All right, so we already have done 3 questions out of the 10. So what I want you to do now is go ahead and pull up your common assessment and answer the rest of the remaining questions. I'm going to give you about 15 minutes to do that. And as you are working, I'm going to pop into your Google Classrooms and give you feedback. All right, so let's go ahead and get started.